Okay, so on to note taking. Question 38. Exponent law for rational exponents. Addison's teacher challenges his team to use algebra and properties of exponents to prove that the square root of 3 is the same as 3 to the 1/2 power. Addison says, well, let's assume there is some exponent that will give us the square root. Addison writes the equation, okay, the square root of 3 equals 3 to what power? So, okay, so there's some exponent out there that's going to give us something that's equal to root 3. But what is it? Is it really 1/2? Or maybe it's something else. So, Imani says, I think we should start by getting rid of the square root. What operation will undo the square root? So what I like about this is that we're not assuming that it's a 1/2, right? We're saying, well, it's something. We don't know what it is, but we're setting out to demonstrate what it has to be. And we're going to do that by starting with the fact that the operation that undoes the square root is squaring. SQUARING. So we're going to square both sides of this expression. And I'm going to turn that into text. Oh, that's cute, squaring. So it says, start with Imani's idea, solve the equation, the square root of 3 equals 3 to the x for x. What does your answer mean? So I'm going to start by squaring both sides. So if I have the square root of 3 and I square that, and that's going to equal 3 to the x, and then that gets squared. Okay, let's see. On the left-hand side, then this should just be just the number 3, right? When I square the square root of 3, I get 3. And then on the right-hand side, if I use the power of exponents, 3 to the x raised to the second is going to be 3 to the 2x power. Okay. Okay. What does that mean, Roberts? What does your answer mean? I don't know what that means. I could say this is 3 to the 1. Oh. Well, this is an exponential equation, right? I've got a variable up in the exponent. And the only way that this can be true, right? If you look at it, I've got identical bases. This has a base of 3 and this has a base of 3. The only way this can be true, right? 3 to a power, right, equals 3 to a power. The only way it's possible for this to be true is if 1 is 2x. And if I solve that for x, I get 1/2 is what x is. What? That did not just happen. So that means legitimately that the square root of 3 is the same thing as 3 to the 1/2 power. X has to be 1/2. Wow. Okay. Huh. That's kind of cool. Okay, can you extend the argument to other radical expressions? Use a similar technique to demonstrate. Oh my gosh, okay, that's scary. So, okay, so I know that the cube root can be undone by cubing. So if I look at the cube root of 17 and I cube that side, and then I can't assume this is 1/3. I'm gonna change that out. I'm gonna say that it's just 17 to some power I'm not sure about. So if I'm cubing both sides, I have to cube this side as well. except I just squared it. I have to cube it. That's cool. So over on the left-hand side, this is just the number 17. And the right-hand side, it's 17 to the 3x power. And of course, this is 17 to the first power over in the other side. So it's the exact same argument. Look at this. I've got 17 to a power equals 17 to a power. Well, the only way this can be true is if this power is equal to this power. So I'm going to say, well, let's let 1 equal 3x, and therefore 1/3 is what x has to be. So, yeah, absolutely. A cube root is, the cube root of 17 is the same thing as 17 to the 1/3 power. Huh. Okay, so let's move on here. So it says, now that you have many tools to rewrite expressions with exponents, use these tools together to rewrite each of the expressions below in two different ways. For example, the square root of 2 to the 5th is the same thing as 2 to the 5th to the 1/2 power, which is 2 to the 5/2 power. Since taking the square root of a number is the same as raising that number to the 1/2 power. Okay. So let's take a look at this. So this a, I can say this is 3 to the 1/2 power to the 4th power. Okay, and that's 3. So this is multiplication here, right? Multiply a power to a power. So 3 to the 4/2 power. And 4 divided by 2 is squared. So this is 3 squared. So that's crazy. If I was to look at that on my calculator, I would get the number 9. So they said just write it in two different ways, but I wrote it in several ways. So the square root of 3 raised to the 4th power is 3 squared, or it's 9. Okay, so let's look at B. So I can see that's got a 1/2 in it, right? It's 7 to the 1. It's 9 to the 7/2 power. I'm going to do this. I'm going to write it like this, 9. Because remember, if I have a power to a power, I would multiply the 7 times the 1/2, which would give me the 7/2. So, and 9 to the 1/2 power is this, well, it is the square root of 9, and I'm raising that to the 7th, and the square root of 9 is 3, so that's 3 to the 7th power. Okay, I would not have expected it, but 9 to the 7/2 is 3 to the 7th power. This is fun. Okay, so I wrote, I don't know why I did that, but there's that again. So this is going to be the same as 2 to the 5th, and then to the 1/3 power. Or I could say this is 2 to the 5/3 power. Sweet. So, oh, I took all those away. I'm sorry. Okay, well, let's do this. I'll let you do 40 on your own. Okay, I won't steal this. So it says match each expression below on the left, letters A through H, with an equivalent expression on the right, numbers 1 through 8. Assume that x is positive. Okay, I appreciate that. So we're going to assume x is positive numbers. So, for example, I'm just going to focus on A for a minute. I'll do A. So we'll look at A together. So that's the square root of x to the third. So I know that that's x to the third, but because it's the square root, it's to the 1/2 power. So that is x to the 3/2 power, for example. And I can see that it's right there, right? So I could say that A goes to 3 and B goes to, so yeah, and you don't have to write all these goes to like this. I guess you could do this. You could say right here, just write a little number 3 next to the A, and 3 goes to A. That's cool. Um, so go ahead and match the remaining ones, and we're going to finish up with 4 more problems, and then you can turn on your 4x4 sheet to Amy before you leave.